For question number 1 regarding gluconeogenesis, when exercising at high intensities and breaking down lots of glucose through glycolysis and glycogen through glycogenolysis, what product is more likely to be formed compared to lower intensity activities? So when we were working out at very high intensities, we're using a lot of our carbs, and so when we break down that glucose and glycogen, we end up with pyruvate. And at lower intensities, when we have a lot of oxygen available, we use our aerobic energy systems, such as the Krebs cycle and the electron transport chain. We take that pyruvate and we convert it to acetyl-CoA, and we send it off to the Krebs cycle to resynthesize ATP. And further, we use that oxygen in the ETC as a byproduct in order to resynthesize even more ATP. However, at those higher intensities, our oxygen levels are beginning to drop because we are not able to take in as much oxygen as we need. We can still take in oxygen and utilize it, but it's not to the high level that we need for the demand that we're placing on our body at high intensities. So we will convert pyruvate to lactate, and we can use lactate and convert it back into glucose through gluconeogenesis. And we can then use that glucose to further supply our muscles with the energy that they need to perform muscle contractions. And so, how does our body utilize this product to maintain blood glucose levels and muscle glycolysis? Clearly state what tissue you are in. So when we go through glycolysis, we have glucose, we go to G6P, and then we have pyruvate, which can either go to acetyl-CoA or it can go to lactate. And when we're at the high intensities, we go more towards lactate. That lactate in our muscle will be transported through an MCT or a monocarboxylate transporter and will enter the bloodstream. Once it's in the bloodstream, another MCT will deliver it to the liver. Once the lactate is in the liver, it'll go through gluconeogenesis or the Cori cycle, where the lactate will be converted back to pyruvate, will be converted back to G6P, and further will be converted into glucose. Now that glucose in the liver will be delivered and dropped into the bloodstream to help increase those low blood glucose levels due to the high intensity exercise that we're doing, and it'll further be delivered to the muscle to fuel muscle contractions and to supply the muscle with the energy that it needs. And for the last part of the question, explain the differences between glycolysis and gluconeogenesis. So for glycolysis, we are converting a 6-carbon glucose molecule into 2 3-carbon pyruvate molecules. And for gluconeogenesis, it's the opposite. We are converting 2 3-carbon pyruvate molecules into 1 6-carbon glucose molecule. So they're just the reverse of each other. And then for glycolysis, it is an exergonic process, which means that we produce more ATP than we use. So we produce 4 ATP and we only use 2, giving us a net gain of 2 ATP. Whereas in gluconeogenesis, it's endergonic, which means we use more than we produce. We use 4 ATP and we only produce 2. And we also, another difference is that we use a GTP molecule in gluconeogenesis, whereas in glycolysis, we don't use a GTP molecule. Another difference is in glycolysis, the PEP or the phosphoenolpyruvate to pyruvate is only one step, and in that we produce an ATP. Whereas in gluconeogenesis, pyruvate to phosphoenolpyruvate is 2 steps and we utilize an ATP. The last difference is that in glycolysis, in the first 2 steps, we use 2 ATP, whereas in gluconeogenesis, in the last 2 steps, we produce 2 ATP. So overall, lactate is more likely to be produced at those higher intensities compared to lower intensities, where we are likely to convert the pyruvate into acetyl-CoA and use it in the Krebs cycle and further use that to fuel the ETC. We can take the lactate in our muscle, we can enter the bloodstream, then enter the liver, go through gluconeogenesis, produce new glucose, put that in the bloodstream, give it back to the muscle. And then the difference is that glycolysis is the reverse, or gluconeogenesis is the reverse of glycolysis. And in gluconeogenesis, we use more ATP than we produce, and in glycolysis, we produce more ATP than we utilize in the process.